Bienvenidos, Ushamdeed, and welcome to this HUD 8 Consulting techtorial on Cisco's Enterprise Networking Security and Automation course, or ENSA, which is part of the new CCNA version 7 curriculum. In this techtorial, we're going to be taking a look at Packet Tracer Activity 5.5.1. And boy, the topology in this one is much larger than the topologies we've dealt with in the previous access control list activities. So IPv4 ACL Implementation Challenge, and this video, and this specifically this activity, has a little something for everyone in it. As you can see here, we have our topology on the left-hand side. The first thing that I want to point out right away is that there is an error in the HQ addressing table, right? For the HQ router here, you can see we list 3 interfaces. However, 1, 2, 3, there are 4 interfaces on the HQ router, and as you probably guessed, the interface not being shown is the interface on which we should be applying an access control list. And so we'll sort that out as we move through. This could be a tricky activity, no doubt. But let's go ahead and take a look at the objectives here. We're going to be configuring some standard named ACLs, some extended name ACLs. We're going to be configuring numbered ACLs as well. We're even going to be applying an ACL to the VTY lines. And I'm going to be pounding home the takeaways from this chapter, right? A lot of the key points that you need to remember. First and foremost, standard ACLs should be placed as close to the destination as possible. Extended ACLs should be placed as close to the source as possible. Now, we've got some instructions here about testing connectivity before we apply the ACLs, and so I'll do that briefly. And all connectivity should and does work. Now, these guidelines, this is where learners are going to get tripped up, and it's specifically going to be this guideline right here with ACL 2 and the requirements for ACL 2. And we'll talk about that when we get there, because I'll show you the #1 mistake that learners make in this activity. So, no explicit deny statements at the end of any of our ACLs. We're going to have a bunch of permit any's, but no deny any's are allowed. We want to use shorthand, and we want to use host when we can. So instead of saying for the branch LAN to branch server, we wouldn't say permit 192.168.2.45 space and then do a wildcard mask of quad zeros. We wouldn't put that in there. We would say host 192.168.2.45. So let's go ahead, let's dive into this activity. Again, it's a very straightforward activity. We're going to see our completion percentage down here in the lower right-hand corner is going to increment as we make our way through. So step #1, let's test connectivity here. I've got PC1 opened up. Let's just check and see, can I ping around my network? What about a 192.168.1.20, right? So can I ping another host on the same LAN? I can. Let's try 1.70, which is in a different subnet. That's the enterprise web server down here in this /29. And you can see the subnet ID is listed for each of the different network segments. And this is very nice because now we don't have to scroll back up into the addressing table when we're working on the activity. And you can see that we've got connectivity there. Can I ping the internet? Let's go ahead and say ping 198.51.100.218. And again, we'll probably have an address resolution protocol packet that goes out, so we'll have a timeout, but then we should have connectivity. All right, so that seems to work well. Let's go over to branch LAN 1, 192.168.2.17. And again, we'll probably have an address resolution packet that goes out that says, hey, I know this IP address, but what is the layer 2 information that I need? The MAC address. And that's going to be our default gateway that we're going to get handed back. And then we're going to figure our way over to that network. And let's try 2.45, which is the branch server. And we spend a lot of time testing our connectivity to that branch server. And you can see everything works great there. The last thing we'll check here is we have a web server, right? This enterprise web server right here. Well, let me see. can I get the basic 192.168.1.70, sort of the basic packet tracer landing page, right? Where we've got small page, we've got some copyright information, as you can see here, and we can move backwards. We've got an image page, which there's the Cisco image, right? All right, so connectivity seems to look good right now. And as we work through the ACLs, whatever it is we're preparing to block or allow, we'll do a quick test to make sure that everything is working. So ACL number 1, 4 total ACLs we'll be working with here. The first one is going to be an extended numbered ACL. Remember, the numbered extended ACLs start at 100 and go to 199. And that's in what I'll call the air quotes regular extended ACL numbered range. And then we're going to explicitly block FTP access to the enterprise web server from the internet. So the source of the traffic is the internet, right? And so everything over here, this is our internet. And again, if traffic is coming in from the internet, it could be coming in from where? Exactly. Could be coming in from anywhere, right? And then let's take a look here at that keyword, right? Anywhere. No ICMP traffic from where? From the internet. And so when you write these things out, it sort of becomes easier to construct what your access control list is going to look like with respect to the access control entries, the ACEs that are in your ACL. So let me go ahead. I'm going to leave that circled up there. And so my question to you is, which router, if we're trying to block access from the internet to the enterprise web server, which is off of this interface on the router, and then the HQ1 LAN off of that interface on the router, and we know it's an extended ACL. And what's that rule? And this is where the rules become really helpful and handy. Again, an extended ACL should be placed as close to the source of the traffic as possible. And I've highlighted the source. It's the internet. And here's where that mistake I previously pointed out in the addressing table, where conveniently the interface that is closest to the source of the traffic, namely that interface right there, is not in the addressing table. So that's kind of the first challenge that you're going to face. I'm going to show you a quick way to test this in Packet Tracer. I would not advise doing this on a live network, but in Packet Tracer, I'm going to show you how I would handle this when it's not in the addressing table. So we take a look here on router 1. We know that the ACL is going to be configured on router 1. So let's go from user exec into privilege exec with the enable command, and then into global config with conft or configure terminal, and create ACL 101. Well, I can simply say access list 101, and what are we going to do? Well, the first one, the first ACE explanation says explicitly block FTP to the enterprise web server from the internet. So access list 101 deny traffic that is TCP traffic coming from anywhere, going to whom? Going to the host, the enterprise web server, which is located at 192.168.1.70. Now, remember, the keyword host is in there so that I don't have to do that. And again, you wouldn't have the keyword host in there if you're doing the quad zeros, but I'm just showing you that this right here that's highlighted, that is the equivalent of that statement right there. And we're using the keyword host because, again, we're being asked to use that as shorthand. I think it makes more sense. I think it's far more readable than to have the quad zeros in there. Again, you may see quad zeros, but here we're being asked to use shorthand, so we're going to use host. Now, the key is, and we saw this in the previous ACL activities that we worked on when working with protocols, we want to check to see, is it equal to what, right? So TCP traffic coming in from the internet that has a destination IP address of 192.168.1.70, but what in that layer 4 header? Again, if we refer back to this right here, you can see we've got the TCP header information. We have a source port and a destination port. Well, if I go back to packet tracer, our ACL says any TCP traffic coming in on any port from any host, but going where in terms of the destination? Going to the enterprise web server on the FTP port. In other words, port 21. So we've just denied TCP traffic from anywhere on the internet going to the host 192.168.1.70 if and only if it's equal to port 21 in that TCP header on the destination port, right? Because again, remember, the source port is going to be some random high port possibly, and especially when we're talking about TCP protocols. All right, so we've explicitly blocked FTP traffic to the enterprise web servers from the internet. Now we're going to say no ICMP traffic from the internet should be allowed to any hosts on the HQ1 LAN. Now, this is where you're going to get caught, and this is where all the learners and majority of the learners will get caught. This is going to be a little tricky, and so follow along with me here between ACL 1 and ACL 2. So access list 101, deny ICMP from anywhere on the internet going where? What's the destination? Well, it says any hosts on the HQ1 LAN. Sorry, I didn't mean to say land like landing gear, but on the HQ1 LAN. And so here's where the conversation's going to start about, okay, well, I can see we've got this 192.168.1.0/26. Well, I know that I've got to have a wildcard mask if I want to capture all of the hosts in HQ1 LAN. So I've got to figure the subnet mask out. Now, there's a couple of ways you could do this. You could do a show run on the HQ router to see what the gig 000 interface that's right there has as its subnet mask. And if you were to do that, you would see it's 255, 255, 255, 192. Now, if you don't want to look at the HQ router and you want to work on your skills, here's an easy way to figure that out. Remember, if it was a /24, the first 24 bits, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8, the first 24 bits, which are going to be all 255s in terms of the integer value here. For the octets, 255.255.255. Again, we've got a /26, meaning we've borrowed 2 of the host bits for the network. And if the last 6 bits, 3, 4, 5, 6, of that octet are for the hosts, then we have the values, right? We know what these values are. It would be 128 for the first bit that we would borrow, and then 64, and that's a pretty bad 4 there, 64 for the second. You add those together, you get 192, right? So we know that the subnet mask would be 255, 255, 255, and I'll just get rid of that 128 there and say 192, right? Because that's what the first 2 bits here in the 4th octet add up to, 192. Well, how do I get the wildcard mask? Well, simply, you're going to subtract the subnet mask, which is right here, 255, 255, 255, 192. You're going to subtract that from the all 255s. And so we know that 255 minus 255 is going to be 0. So we'll say 0.0.0. And now, what is one? If I have 255 and I take away 192, I'm going to end up with, and I'll get rid of the 64 there, I'm going to end up with 63. So here is my wildcard mask, 0.0.0.63. Now, remember, I want you to remember, where's that? Right here. Because this is where that's going to get interesting. Because if you're looking at this and saying, oh, no host on the HQ LAN, this is ACL 2. When we get here, you're going to look at that and you're going to say, well, I already know the subnet ID and the wildcard mask, and I'm going to use that. And that is where you would end up being wrong. And so we'll talk about that when we get there. And again, this is probably the most difficult thing that learners run into with this activity. But back to no ICMP traffic from the internet should be allowed to any hosts on HQ LAN 1. Well, we know what the network ID is. It's right here, 192.168.1.0. And we know the wildcard mask now, which is going to be 0.0.0.63. So let's go ahead. I'm going to leave the writing up there because it's not in the way yet. And we're going to deny ICMP traffic from anywhere going to network 192.168.1.0, 0.0.0.63. Now, if I do a question mark here, at the CCNA level, you probably haven't gotten into this, right? But you can actually filter ICMP based on the packet type. It could be a TTL exceeded packet, maybe a host unreachable, or an echo reply, or an echo request. And they have it listed there at the top as echo ping. So I just refer to that as the echo request, and then you're going to get back a reply. So you could filter on certain types of traffic, but here, certain types of ICMP packets, but here they're just simply saying no ICMP traffic from the internet should go to HQ LAN 1. And then it says allow all other traffic. So remember, we're going to say access list 101, permit IP any, right? And that's sort of our catch-all. And you can see the completion percentage at the bottom just jumped to 19%, telling us that we've done something right here. Now, the next step, again, remember we've got a mistake in the addressing table. The interface to which you would apply this is not in the addressing table. And so we're going to say do show IP interface brief, and I'll show you how I would handle this in Packet Tracer, right? In the real world, there's going to be different things you're going to want to do other than shut an interface down to check to see, hey, is that the right interface? But when we look at this, you can see right here, we've got a 192.0.2.1, and I believe it's in that RFC 1918, or I'm sorry, yeah, it might be in the 1918 range, sort of the internal or used for documentation range. And that looks a little odd, right? So chances are that's it, because 192.168.3.1 is probably in the network somewhere, although when you look, you don't actually see it. But if we scroll back up over here, you can see that serial 011 is 3.2. And so that's kind of a giveaway, in a sense, that we know that it's going to be serial 010, even though they left that information out of the addressing table. Serial 010, IP access group 101. Now, what direction? Which direction is the traffic coming from that we would be blocking when it's sitting on this outside internet-facing interface? Exactly. It's going to be coming inbound from the internet, because we're looking at the inbound source address, which we have as any address. And then we're going to check to see, where is it going? What's the protocol? How is it going to be trying to connect, right? Is it ICMP? Is it FTP? What's going to happen there? So we've jumped up to 27%. You figure you got 4 ACLs we're going to be working with here. So it's going to be right around 25% per ACL. All right, so that takes care of ACL 1. Now, we're going to move on to ACL 2. And here's where it gets a little bit tricky. And learners typically will trip up on ACL number 2. So use ACL number 111, right? That's not the tricky part. The tricky part is what I've circled here. So the first requirement, and let's come on down here, and let's go ahead and say access list 111, and it says no hosts on HQ LAN 1 should be able to access the branch server. So we just figured out what the network ID is, which is right here, and the wildcard mask, and use that in the previous access control list, number 101. And so when you look at this, your learners will immediately think, oh, well then here's the command that I should have. Access list 111 deny IP from the 192.168.1.0.0.0.63 going to the branch server host, which is 192.168.2.45. So a couple of quick things here. IP, when you say deny IP or permit IP, right? Like we just did right up here, permit IP any, IP represents all protocols. So if I'm denying the IP protocol, I'm in effect denying all traffic. And so that meets this requirement. No hosts on HQ-LAN 1 should be able to access the branch server. Now we know we're dealing with an extended ACL here, right? And here's where I'm going to clear the screen for us. We're dealing with an extended ACL. Extended ACLs are best practice placed as close to the source as possible. So what is my source? Hosts on HQ-LAN 1 should be able to access the branch server. So it's HQ-LAN 1 is my source. If I want to place this ACL as close to the source as possible, it's going to be on this interface right here. Now, this is where it gets a little bit tricky. You've got this access control entry here, which technically will work and technically is correct. However, Packet Tracer is not going to give you points for this. And so here's why. If I'm denying traffic from that subnet and only that subnet resides on that interface, isn't this the same, this syntax right down here, isn't that the same as saying anything from that subnet which sits on this interface? And it is, and it's going to go right back to this little caveat right here. Use shorthand, host and any whenever possible. And so this might not be apparent initially, but when you think about it, if you use that syntax right there, it's the same as this in shorthand, because when placed on that interface in the inbound direction, right, you're saying anybody coming from this subnet. And so we can use shorthand. We couldn't do it over here, right? Because on that interface, we've got 3 other interfaces to which traffic could be going. And this is an external facing interface. So we wouldn't say any, because then that would block all inbound traffic. We don't want that. But here, and I hope that you see this, because it's only this subnet that's on that interface. So instead of writing it out longhand, we're going to use the shorthand any. And again, that is the number one challenge and the number one mistake. And learners, I think it gets them to 84 or 86%, I think is what it is, when they have the ACL and it's right and it's working, right? And it does what it's supposed to do, but they're not getting the points for that. And the first question they ask is, well, why is that? Because it's hitting the ACL when I have the 192.168.1.0 and the wildcard mask in there. And it's because this is what Packet Tracer is looking for. Are they both technically correct? They are. Are they both doing the same thing? They are. But we've been told use shorthand whenever possible. And this is one of those possibilities. But again, it comes right after you do this in Access List 101, and so learners are quick to immediately put in the subnet ID and the wildcard mask for the HQ-LAN 1 subnet, and then they don't get the points, and it's not clear as to why. So hopefully that makes sense. So let's knock this out, host 192.168.2.45, and we're just denying all traffic. And you should see that the completion percentage from 27% is going to move up here as we move along. Let me just reread that. No host should be able to access the branch server. So we'll put that on there, and then all other traffic should be permitted. Access list 111, permit IP any. And you see we jumped to 42% right after we complete that ACL. So now we know it's going to go on interface gigabit Ethernet 000. And let's make sure. Hold on one second here. Yeah, okay. Just checking something. All right, so we're on interface gig 000, do show IP interface brief, just to confirm, and you can see the 192.168.1.1. And remember, we were able to ping the branch server from PC1. We didn't check PC2 and 3, but assume that they would work. So now when I get into interface gigabit Ethernet 000 and I say IP access group 111 in the inbound direction, our completion percentage jumps to 50%, right? Because now we've completed 2 of the 4 ACLs. But let's go ahead and let's now try to ping over to the branch server in branch LAN 2. And what do we get? Destination host unreachable. The ACL is blocking that traffic. If I try to do it from PC2, we'll say ping, sorry, was off there just a skosh. Ping 192.168.2.45. Destination host unreachable. And PC3, we'll go ahead and say ping 192.168.2.45. We get the same thing if I try from the admin PC, and let's kick this guy open up. It doesn't do much during this activity, but we'll open him up anyway. And we'll go ahead and say ping 192.168.2.45. And you can see he can get there, right? Again, the ACL is placed on this router interface in the inbound direction, which is connected to the HQ LAN 1 subnet. All right, so that's ACL number 2. Let's jump to ACL number 3. Create a named standard ACL. Use the name VTY_block. The name of the ACL has got to match exactly. And only addresses from the HQ LAN 2 network should be able to access the VTY lines of the HQ router. So what is this saying? HQ LAN 2 is the only subnet, and it's right here, 192.168.1.64/29. We've got that variable length subnet masking. The VLSM is in play here with this 192.168.1.0/24 network. We carved out a block of IPs with a /26, and then we picked up at 64, and now we're going to carve out a block of IPs using a /29. So, HQ LAN 2, what is this ACL going to look like? Well, it's a named standard ACL, and so we know that it's going to start with IP access list standard, and we can put a number or a name. So what are we going to do? Well, again, this is going to be named VTY_block. And so here is where you could, if this ACL existed already, we could make changes to it. We could remove sequence numbers, add in new access control entries with a specific sequence number, put a remark in here of some kind. But we have to first figure out if we're permitting traffic from the HQ2 LAN, and again, that ACL is going to get placed on, I'm sorry, I didn't mean to motion to that interface there. It's just kind of where I was grabbing the mouse. That ACL is going to be placed on the router on the VTY lines, right? Not on an interface. And so what we just did previously with ACL2 by saying any, if you're thinking that, oh yeah, well, I'm going to put it here on that interface. No, remember, we're talking about a standard ACL, and it's going to be applied to the VTY lines. So it's not going to be applied to that interface right there. This is another common mistake that learners will make if they figure out ACL number 2 and they see this no host on HQ LAN 1. They think, well, oh, well, I'll put the ACL here. But remember, it's a standard ACL, right? And it's applied to the VTY lines. So it's not applied to the interface. So we're not going to be saying any. Again, this is a simple yet very tricky little activity depending on how you interpret a number of the things that you're being asked to do here. So let's take a look right now then at, let's get the pin back up. Let's take a look right now. Here is the HQ2 LAN. Remember, HQ LAN 1 starts from the, and I'll put it up here at the top, starts from .0. My first usable up here is .1, and my last usable is going to be .62 because my broadcast address is .63. And so there is a variable length subnet mask that we used. We have this whole 24, right? And I carved up part of it to right size for this subnet here. And then down here, I pick up at the next network, which is going to be .64. That's the network ID. So my first usable is going to be .65, which I believe is the IP of that interface. And then we're about to find out how far this is going to go. And the block size, if I'm not mistaken, is going to be, we'll sort it out here. So if it's a /29, there's two ways for me to figure out the subnet mask length, right? I could take a look with the do show run command from the configuration mode that we're in right now, or I could simply say the last octet, again, and I'll do squigglies here for 255.255.255, and it's going to be all ones because these are all subnet bits. And now I'm borrowing the first 5 because if these are 8 each, right? 8 bits, 8 bits, 8 bits. We've got 24 bits here, 25, 26, 27, 28, 29. Meaning 1, 2, 3, 4, 5 host bits in the last octet have been borrowed, leaving only 3 host bits left. And so these 5 network bits that we're using, this is where we can figure our block size out. And it's going to be a block size of 8. But remember, the leftmost bit in an octet is going to have a value of 128, and then 64, and then 32, and then 16, and then this guy here is 8. So my block size is 8. So we're going to start at 64, and then it's going to end at 70, or I should say the next subnet would start at .72, meaning 65 is my first usable. And let me do this. I'll scratch these guys out here because it's kind of getting crowded. So 64 is the network ID. 65 is my first usable IP. My last usable IP is going to be 70. And the broadcast IP is 71. And then the next network, whatever subnet mask length it might be, is going to start at .72. Again, this is making sure we're using the right appropriate subnet mask length, right? A 26 here because maybe they're going to have more PCs, a /29 here because we've got an admin PC and a web server, that's it. So again, we would pick up at .72, but for our purposes, the block size is going to be 8. And what would the value be of this subnet mask if we add these 5 leftmost bits up? 128 and 64 is 192, and 32 is 224, and 16 is 240, and 8 is 248. So without drawing out the all 255s, and we know that the first 3 octets here are going to be all 255s, it's simply going to be 255, and we subtract 248, well, that should be pretty easy. You're going to get 7, right? Because 248 plus 7 gives me 255. And here's the usable range of IPs in this subnet. And you can see that matches. There's the .70, there's the 67. I think 65 is on that interface there. So now we know the subnet mask value. We know the wildcard mask value is going to be 0.0.0.7. All right, so let's dive in and let's make that happen. Let me clear the screen here and get control back of the mouse. And so we're back to this ACL. And what is it? Only addresses from the HQ2 LAN network should be able to access the VTY lines. And so we're going to permit 192.168. It's a standard ACL. Let me come back here real quick. It's a standard ACL to show you. I don't get to say permit IP or, to trim it down so it's only SSH that's being allowed in. No, right? I can pick the source of the traffic, and the source for this traffic is 192.168.1.64. Remember, that is the network ID, and the wildcard mask is 0.0.0.7. And that's it, right? That is your standard ACL. Much simpler, much easier to handle than the extended ACL in this instance, right? So what do we have to avoid here at the end, right? The temptation is to go ahead and say deny any. But remember, do not use, up here these guidelines, do not use any explicit deny statements at the end of your ACL. So for all intents and purposes, we've created this ACL, standard named ACL. We're permitting only hosts on that network, right, admin and enterprise web server, to be able to access the HQ router VTY lines. I don't need to say deny any, because even though it's a best practice and in the real world that is what I would do, they've asked us not to do that here. And you can see the completion percentage jump to 62. So this ACL is actually done. Now we just need to go into line VTY 0 through 4, and this is also a sort of a snafu type thing. Let me pull up a real Cisco router just ever so quickly here, and I apologize that this is not up, because this is actually important in terms of, and router 8 should be working, I'm hoping. Okay, fantastic. So, and this is important, right? So if I go to privilege exec and into global config and I say IP access list standard VTY underscore block, and I'm just creating this on a real Cisco router, and I say, permit. If I say permit 192.168.1.64 0.0.0.7, and then I go into line VTY 0 through 4, I want you to pay close attention here as to how we would apply this on a real Cisco router. If I do a question mark here, you can see access list, right? Filter connections based on an access list. Now, there's also this IP for IP options. So watch this. If I say IP question mark, you can see that it says netmask format or TCP options, right? So the command to apply this is going to be access class, the name VTY underscore block, and then is it incoming traffic I'm trying to block or outgoing traffic? And remember, there's going to be incoming requests to connect to this router over the VTY lines. So access class works great. But I want you to pay attention to something. Again, this is just kind of like a little sidebar here. So here I am on this router. If I say IP question mark, take a look at what it says. So they would have you type IP access class if you're using an IPv6 access list. And that is not how it's done on real Cisco routers. So be aware of that. When we talk about IPv6 and applying IPv6 ACLs, Packet Tracer has you do it like this by saying IP access class. And if you look, if I was to do a question mark here, they have IPv6 options. So if I say IPv6 question mark, then there's the access class. So it's assuming that you're typing in IPv6, whereas on a real Cisco router, there is an option for IP that is not IPv6. So be very aware of that, right? Be very aware of that, that on the Packet Tracer side, when you type in IP question mark, it gives you the impression that there's a mistake here, because I should have to say IPv6, but it's matching the letters I and P. And in Packet Tracer, you can see they show the IPv6 option. There is no IP option here, which is why when you say IP, that is what it thinks it is. So make sure you're aware of that. So again, to apply this, we're going to say, ACCESS, access class VTY underscore block in the inbound direction. The percentage goes to 68, and now we come down to ACL number 4. So create a named extended ACL called branch underscore 2 underscore H2. The name of these ACL's got to match exactly. So here's where it's going to ask us or tell us what we're supposed to do. No hosts on either of the branch LANs should be allowed to access HQ LAN 1. So these two branch LANs, branch LAN 1 and branch LAN 2, should not be able to access anything over here on HQ LAN 1. So you're probably already thinking, well, this is going to be an extended ACL because we're talking about the source, we're talking about the destination, and it tells us right there, extended ACL. So you might be thinking, I need to get it as close to the source as possible. Well, what happens when you have two locations that would be as close to the source as possible? Because this is as close to the source as you can get. However, they've got a caveat in here. Use one access list statement, one access control entry for each of the branch LANs. So one ACE access control entry for each of the branch LANs, which should be telling you that you're probably not going to place this ACL on these two interfaces, right? Because if you have a single ACL that reflects denial of traffic from that network over to HQ LAN 1 and denial of traffic from that network over to HQ LAN 1, you'd have two statements, but if I apply it to this interface, there's going to be one statement that's never used. And if I apply it to that interface, if I apply it to both of them at the same time, there's still going to be an extraneous entry, depending on which interface we're talking about, that denies traffic for a LAN segment that is not on that interface. And so when you run into issues like that, and I love how they set this up, this ACL 4, right? Because this is where, yeah, the best practice is get it as close to the source as possible with an extended ACL. However, here's a case where that is not the best way to do it. The best way to do it is to drop it on that interface there, or you could have one ACL just with this subnet and then a second ACL, right, with just that subnet, and then you put this ACL on that interface and then this interface gets this ACL. But that's two ACLs. Again, multiple ways to do it. But when we're in this situation here, where this is what we're being asked to do, we're going to put it on this outside interface right here between the HQ router and the branch router. And this is like, could be a T1, a T3, you know, we could be using AT&T, whatever the case may be. So we're going to go on this interface, and then the traffic we're looking at, right, the source of the traffic, it's going to be going in what direction with respect to that interface? Is it coming into that interface, or is it flowing out of that interface? And if you're thinking it's in the outbound direction, you're absolutely right. All right, so we know what to do. We've looked at the caveats. Let's go ahead now. Let's get into global config mode over here on the branch router. We know it's going to go on the branch router. All right, so we're going to get into global config. Let's say do show access list. And they're going to have us do some pretty extensive verification down here. And there are some questions at the bottom, and I'll give you the answers to those as well. We've got no ACLs configured on here. So, oh, sorry, we're in global config. Named extended ACL. Remember, we have to start the command with IP when we're doing a named extended ACL. So IP access list branch, extended branch underscore to underscore HQ. And what are we going to do here? No hosts on either of the branch LANs should be allowed to access the HQ1 LAN. So what we're saying is I'm going to deny IP, and since it's not just on this interface and just on that interface or on both interfaces, I can't say any, right? I can't do what we did over here with ACL 2, which was really tricky on their part, but they were clear up here to use shorthand whenever possible. You would just need to recognize that that's an opportunity to use the any keyword. But here we've got it on this outside interface. So I can't say deny IP any because we've been told we need an individual statement for both of those branch LANs. So deny IP from, and we'll start with the first branch LAN, 192.168.2.0, but what about the wildcard mask? And so again, we've done, oops, sorry, I did not mean to do that. So we've done this a couple times, and so we'll kind of take the shortcut here. So if it's a /27 in that last octet, that would mean the first 3 bits have been borrowed, meaning 128 plus 64, which is the second bit, plus 32. So that's going to be 192, 224. And if I subtract 255 from that, right? And hopefully these are nice little shortcut ways to figure these things out that you look at and say, yeah, that's pretty cool. And that's actually what I would end up using when I'm working through a problem like that. So 25, 26, 27, we match the /27. The block size is going to be 32, which means if we start at .0, the next subnet network ID is going to be .32. Right? But then they use a little variable length subnet masking, and we'll talk about this guy here in just a second. So they've got this, it looks like the 192.168.2.0, and they're doing variable length subnet masking in the branch LAN, right? And so I'll even write that in here, 192.168.2, whoa, I didn't want to do that. Let's wipe that out. .2.0/24, right, is probably what they're using in here in the branch side of the house. And then we're going to subnet it. We're going to do variable length subnet masking. We're going to use a 27. We're going to use a 28. And so the wildcard mask for that network, this subnet, is going to be 0.0.0.31 because 224, when subtracted from 255, is going to give us a result of 31. So I'm not going to erase that. We're just going to pull that back. We'll pull the router back up here, and let's get that subnet mask in here, 0.0.0.31. So deny IP all traffic, right? Deny all IP traffic from this branch LAN 1 subnet going where? To who? And it says the HQ1 LAN. And so here is where we do have to come back and use, and we already figured this out, 192.168.1.0, and we know that it's 0.0.0.63. Right, so the completion percentage right now is at 68%. And now we've got to sort out the HQ LAN 2. And the statement is going to be the same. Deny IP coming from 192.168, or at least the start of the statement is going to be the same, .32, but what is my wildcard mask value going to be? So again, we take sort of the little shortcut that we figured out. We look at the subnet mask length of 28, meaning in that last octet, the first 4 bits, leaving 4 host bits. The first the leftmost bits, the first 4, have been borrowed for subnetting. And so the value is going to be 128, and then 64, and then 32, and then 16. So my block size is 16. So we know the first subnet goes from .0, the next subnet starts at .32, and then the next subnet, because I'm taking a block size of 16, is going to start at .48. And that is what variable length subnet masking is all about. So the first network, there's the broadcast address, and you can fill in the usables, right? .1 to .30. And then over here, the second subnet is going to be .32 to .47, and we can see the usables are going to be .33 to .46, right? And that's exactly how it works. When you want to right size your subnets and you want to conserve your IP address space, this is how you make that happen. So now that I know the values of each of these positions and I know my block size, I can easily figure out 128 plus 64 is 192, plus 32 is 224, plus 16 is 240. And this one you don't even have to think about. You can figure out that if we do that subtraction right there, we end up with .15. And so the wildcard mask here is going to be 0.0.0.15/28. So I'll actually, I'll just leave that on the screen for right now. So we'll come down here and let's get that filled in, 0.0.0.0.15. And we're going to be going over to that same 192.168.1.0.63. And so all other traffic should be allowed, and it's here when I say permit IP any, because this is an extended named ACL. When I hit enter here, we should see some action on the completion percentage, and it did. It jumped 20 points. So we're now at 88%. And let me make sure I got everything right here. We got the branch ACL. All right, so we need 12 points, and I'm assuming that when I go into, sorry, not line VTY, when I go into do show IP interface brief, it's probably serial 011, and it is, that's serial 011, interface serial 011, and I say IP access group, and we name this, I got to be careful here, branch _2 _ HQ, in the outbound direction, right? That was I almost typed inbound. So it's in the outbound direction because that's the direction traffic's going to be flowing. I hit enter, completion percentage at 100. So let's answer these questions over here. We're going to perform the following connectivity tests. I'm going to clear the screen now. We're going to perform the following connectivity tests. And they actually said, you use the clear access list counters, but we're going to fly with it just as it is. And so this is what we're going to be working on right over here. So send a ping request from branch PC, and here's the branch PC, and we're going to send it over to the enterprise web server. So 192.168.1.70, and it's asking us, was it successful? And the answer is absolutely it's successful because the ACL that we placed here, right, is blocking traffic from these LANs to the HQ LAN 1. So the question they ask you is which ACL permitted or denied the ping between these two devices? And that's going to be easy enough to figure out. We'll come over here to the branch router and we'll say do show access list because this is going to show me where my matches are at. And again, we could do a clear from privilege exec. Again, and let me do that. I'll show you how to do the clear access list counters. They don't tell you where to do that from, but you do it from privilege exec. And here you can see that we got the matches that we were looking for. Again, if I was to pull the branch PC up and rerun this again, and then pull the branch router up and then rerun that command, we should see 8. And there we go. And so the question, which ACL statement permitted or denied the ping? It's access control entry 30 that's on the branch ACL that's part of the branch to HQ access control list, right? So you've got the ACL statement, the ACE, the access list name is the branch to HQ, and the router on which it's applied, the branch router, the specific line is access control entry 30. All right, now let's attempt a ping from PC1 to the HQ LAN 1. So we're on PC1 over to HQ. I'm sorry, allow a ping from PC1 on the HQ LAN 1 to the branch server. So let's go ahead and say ping, and I think we actually have that here, 245. And we get destination host unreachable. Was it successful? The answer is no, and explain why. And it's because we're blocking that traffic, and it would be on the ACL statement right here. Let's pull this up on the HQ router and let's say do show IP access list. And you could just say do show access list. I just put the IP in there. And remember, we are denying all traffic from any host, from any device on that resides on that interface. And this is ACL number 111. This was the tricky one, because it's placed here and we're looking at traffic in the inbound direction, right? In the inbound direction, but it's any traffic from that subnet going to or trying to get over to the branch server, it's going to be blocked, right? And so if I was to rerun this, let's rerun that command. Let's go to PC1. Sorry about that. Rerun the command. We get the destination host unreachable. We'll pull this back up. We'll rerun that command. And now the matches have incremented to 20 by 4 because we sent 4 ping packets. So to answer their questions, which ACL statement permitted or denied the ping? It's ACL, it's access control. Sorry, are we off a bit? No, yeah, it's access control entry 10. That's part of ACL 111 applied to the HQ router in the inbound direction on gig 000. All right, we're getting down to the end of this activity here. Open a web browser on the external web server. And let me clear the screen for us here. On the external web server, let's kick open a browser and let's browse to HTTP 192.168.1.70, which is the enterprise web server. And take a look at that. The traffic works like a champ. And the reason that the traffic works, and let's see if we've got the image there, is that Cisco image we all love so much. Well, we know it's going to be coming in to this interface on the HQ router. So if we took a look at the HQ router, my guess is it's going to be access list 101 because it's applied to that interface in the inbound direction. And it's going to be this permit IP any. Again, that's if I had to guess where we're hitting. And take a look. There it is. So which ACL statement permitted or denied the, I'm sorry, enterprise web server, is it successful? Explain. permitted or denied the ping. This asks for a ping between these two devices. So this, when you read this, it's a little incongruent here, right? It says open a web browser on the external server. We did. Attempt to bring up the web page stored on the enterprise web server. We did. Is it successful? Yes. Explain. Because the traffic's being permitted via access list 101, access control entry number 30, which is the permit IP any, because it's placed on the HQ router on the serial 010 interface. But then it asks you which ACL statement permitted or denied the ping between these two devices. And again, we're not pinging, we were using the web browser, but let's see if the ping works, because I think they might be trying to get us into a scenario 192.168.1.70. I don't believe this is, or it is going to work. Okay, so the ping from the external web server works because if we go back to the ACL here, we're denying ICMP from anywhere going to the HQ1 LAN, meaning the ping packets that are going to other HQ LANs, i.e. HQ LAN 2, that is going to be allowed. And so again, we run that test for those same two devices and it works, and we know that it's access control entry 30 is allowing those packets to go through as well because it's permitting everything else. So test connections to an internal server from the internet. So from the command line on the internet user PC, let's get that guy up. Here's our command line. It says FTP to the branch server. So 192.168.2.45 Cisco. Oh, sorry, and that's a typo there. If we rerun the command, it will work. Cisco. There we go. Right? So we're in FTP mode. And so is the FTP connection successful? Which ACL list should be modified to prevent the users from the internet to make FTP connections to the branch server? So it's successful because if I rerun that command, you can see it's hitting the permit IP any. Now, remember, that is probably going to be going up exponentially because all traffic from the internet that is allowed is hitting that access control entry, right? Here are the ACLs where you want to keep an eye on whether traffic is incrementing exponentially or not, because that may mean that someone might be trying to sort of fingerprint your network or do some, it's not forensics, not the word I'm looking for, not scavenging. It'll come to me in a second. So I'm just drawing a blank on the word I need to use here. But so if they're trying to map your network out, right, and reconnaissance and doing some network reconnaissance using ping, you know, if you see this going up a ton, you want to keep an eye on that. So the question is being asked, which ACL should be modified? It's going to be ACL 101 that needs to be modified to prevent connections from users on the internet, so from anywhere on the internet to the branch server via FTP. Well, the statement is going to look almost exactly like this statement right here, except host is going to say 192.168.1, I'm sorry, .2.45. Now, the tricky part, again, is if I just go in and type in to this statement, deny TCP any host 192.168.2.45 equal to FTP, it's going to drop it to access control entry sequence number 40, right? And so the deny would be after the permit IP any. That's going to be a problem. So that is where when you come in to make that change, you're going to specify the sequence number. And you could use 15, you could use 25, but it's got to be less than, strictly less than. You could use 29, but it has to be strictly less than 30, because that's where we find the permit IP any. And it says which statement should be added. Well, we already talked about that. It's going to be this statement right here, but the host IP is going to be for the branch server. All right, well, this was a monster activity. Lots of things going on, lots of subtleties with this activity in terms of the nuances with shorthand versus longhand versus which interface. And so hopefully you were able to take all that in. This is a phenomenal activity, So I wish you the best of luck in your studies. Thank you so much for watching, and I hope to see you in the next video.